Hello everyone, I'm Vishesh Vabhuv, and right now we're starting with module 3, that is GCCF Networking and Security in Google Cloud. Well, this is the theory part of it, and after this we'll be uploading the practical part. Let's start with the theory first. So we'll first talk about a bit about the Google network, so how that is configured and how it is important for us to use, right? So we'll just talk about that and we'll try to know more about it. So let's get into a background of networking. So this is the Google Cloud network right now, right? You can see this. All these blue dots are the current regions with 3 zones. So every region has 3 zones right now. So as you can see, even Delhi and Mumbai has one. So these are the zones, current regions, as we discussed in the first theory video. Regions and zones, what are they? And these are the future regions with 3 zones. So these are the future regions that are coming up by Google Cloud Network. Well, if you look at this is actually a diagram telling you more about which service is available at which region. So you can understand it by looking at it. So Compute Engine is available in Mumbai and Delhi. App Engine is available in Mumbai but not in Delhi. So it does not mean that people in Delhi cannot use it, but when you try to actually create an app engine in this region, Asia South 2, you won't be able to do it because it's not really available in that region. So I hope you understand the part how does it really happen. Now let's come to Google Cloud Networking. What is it? So first of all, before getting into that, let's talk a bit about VPCs, which are virtual private clouds, and we'll be doing a bit of the labs on VPCs. But just to understand what are VPCs, they are software defined network, which actually, just think about it like there is a physical data center, and then we are making it a virtual private cloud by giving it a space and like some space of that data center, and making it as a virtual private cloud. So now it is a virtual private cloud. So a whole network, a whole server is now configured into virtual private cloud, which is a small part of a big network. So that is how you can actually understand what it is, right? So these allow the deployment of infrastructure as a service resources. It allows us to actually deploy those infrastructure as a service resources. Then it does not have any IP address ranges. It is global. It's not only regional, it's global, and it contains subnets. What are subnets? Well, think about it as parts of like large networks. So there are large networks, and then if you divide them into small subnets which are actually regional, then you can get subnets. So we'll understand more about this. So let's talk about VPC. So a VPC network, virtual private cloud network, is a virtual version of a physical network, and it is a global resource. We talked about it, right? So just look at this. Look at this diagram. So there's this on-premise server which runs behind a VPN gateway. Now this VPN gateway connects us to the different regions. So this is the region US East 1. It has 2 zones right here, 2 zones right here. US East 1A, US East 1B, and these are these virtual machines that are running in compute engines you can talk about, and it is subnet of its own. So like something like this, these are the subnets, and same through internet. So there's this internet, it runs behind the internet gateway, and then it's the VPC routing. This is virtual private network gateway. We all use VPN, right? So you might have an idea what VPN is, but it's how this really works when you're working on an on-premises server. And then it's the internet, the cloud, and then it runs behind the internet gateway, and then VPC routing connects us to the zones. And then these virtual machines or these compute engines are the neighbors. So a subnet can have like these two neighbors who are virtual machines who are neighbors. So this region has a zone, and this zone has these virtual machines which contains the subnet, and this is how a subnet is actually made. So if you think about what is /24/24/16, we'll talk about that in the later videos, in the later slides. Alright, so subnets are actually regional and extend zones in the same region. So as we talked about, they are regional and they extend zones across the region. So just like this, right? This is what they are doing. They are extending across zones in the same region. So think about it like this, right? So this subnet is like spreading across zones in the same region. So right. So what is the difference between auto and custom networks? Well, there are two types of subnet networks. One is auto and one is subnet, or one is custom. Well, the auto is actually managed by Google. That means that one subnet from each region is automatically created, and like after you add, like if you add a new region or a new subnet, a region is assigned to that. So one subnet from each region is automatically created. That's something to remember. And a set of predefined IP ranges is given if we are creating an auto subnet mode. We'll be creating one auto subnet and one custom subnet in our labs, so we'll get to know about it. And it comes with default firewall rules. We don't have to specify custom firewall rules, and it is only expandable up to /16 only. Well, what is this? We'll come to know about it in the next slide. It is also good for isolated use cases like proof of concepts or testing. So it is good for auto subnet mode. Well, what is custom subnet mode? No subnets are automatically created. You have to create that manually. Well, subnets and IP ranges are defined here. You define that what range to what range a subnet and IP range should be, and there are no default firewall rules, so you'll have to give the custom firewall rules as well. And it is expandable to any RFC 1918 size. So that's something that comes in a network way. So if you read more about the networks, you'll learn about these sizes also. And it is recommended for production environments. So this is for proof of concepts and testing, and custom is for production environments when we are actually working on the product. So a VPC is made up of subnets. We talked about that, right? So subnets need to be configured with private IP address range, right? They need to be configured with private IP address range. So IP address is something that we did not talk about. Well, IP address is your internet protocol address, right? And every website you use has an IP address of their own. Just like google.com also has an IP address, right? And every website that you own has a IP address of their own. Just like VPC. VPC is made up of subnets, and these subnets need to be configured with private IP address range. So it cannot match with any other IP address that is always there. So there is also a debate where we think that can we run out of IP addresses? So we thought that we would be running out of IP addresses. So then we discovered two ranges, so IPv4-6, IPv4 and IPv4-6. So now we have solved that issue of running out of IP addresses just to make it too unique. So IP addresses are used for internal network communication. So how does the internal network know I want to route to this website, this particular site, or this particular location? How do I do that? Well, IP address do that for you. They are kind of serve as a location, as a protocol for you to actually navigate to that place. And each octet is represented by 8 bits. So this is the octet, and these are all represented by 8 bits. So all of that, like an subnet IP address is made up of 32 bits. So that's how you know. And the slash and the number determines the number of address bits that are static. So this number actually determines that number of address bits that are actually static. So this is how it does. Now a /16 range will provide 65,536 available IP address, right? Which means this is a CIDR range and determines how many IP addresses are available for, like, if we go with a subnet that has /16, that means we can get up to 65,000 IP addresses, like 536. And every one you add, like 16, 17, it gets half. So 16, it was 65, then it was 32, then 16, 8, 4, something like that. So every one you add to this, it gets half, right? Okay, now we come to public and private IP addresses. Now so what are they? So there's this internal IP and there's this external IP. So internal IP is allocated from subnet range to virtual machines. So we created some virtual machines, remember, and it also gave us some internal IPs and an external IP. And this DHCP, it is done by DHCP, which is a protocol, and DHCP lease is renewed every 24 hours. So whenever you are using this internal IP, you are leased this internal IP by DHCP, and it is renewed every 24 hours. So you are billed according to that. And virtual machine name and IP is registered with network scope DNS. So it is pretty self-explanatory. So a virtual machine name and IP is registered with network scope DNS, which is domain name system. So this is how it does. Right. So now we come to the external IP. So what are external IP? So they can be assigned from pool or reserved. So we understanding what are pool and reserved when we'll be doing the labs. So you understand it better when we'll be creating these IP addresses. And they are built when not attached to a running like virtual machine. That is how it is built. And if you're working on the cloud, you need to know that if you are not really building these things unnecessarily, so that's really important. And virtual machine doesn't know the external IP. It's mapped to the internal IP, which are then connected to the virtual machines, and then which is used by the external IP address to connect to the internet. So that is how it all works, right? Now the primary products included in Google networking are virtual private cloud (VPCs), cloud load balancer, cloud CDN, cloud interconnect, and cloud DNS. Well, virtual private cloud is what we talked about. It is managed networking for resources. It is like categorized by subnets. Then comes cloud load balancer. Load balancing is actually a thing where we make sure that, okay, so if a website or an application is using a region and only one region, and if there's a spike in the number of users, then we don't know if that application would keep performing in the same way it is performing. So what load balancer actually does is it splits the load into two regions or zones. So it makes sure the region will be the same, the zones would be different. So it just makes sure that the load is just balanced and the application has no impact on its performance. So that's what load balancer does. It does auto scaling. Now we come to Cloud CDN, Content Delivery Network. You must have heard of Cloudflare, or if you have visited a website, you must have come through like a Cloudflare kind of a thing that comes before visiting a website. It's actually a content delivery network. It makes sure that the content is delivered to you with the nearest server possible. So it might be that the website you are using is actually located in the US, but you are in India, which are miles away. But for example, just to make sure the process is faster, we use Cloud CDN, which is like Cloud CDN is for Google, but we use content delivery networks to actually deliver it to our mobile phones through the nearest servers. That's all. And Cloud Interconnect actually makes sure that every application has interoperability and they're all connected through the cloud. So Interconnect does offers us a high availability interconnect. And DNS, as the name suggests, domain name system, it gives us these names like google.com has this DNS, so we know that okay this would take us to google.com. So that is something like cloud DNS is, right? Well, this doesn't actually take you to Google, but there is some DNS or IP address that actually takes you to Google. I am not sure about that. Okay, so what are firewalls? So firewalls actually protect virtual machines or anything like which needs to be protected. Virtual machine instances from unapproved connections. So there might be some unapproved connections or things that we don't want to happen. So firewalls protect us from doing that. So VPC network functions as a distributed firewall. So there are distributed firewall. They make sure that like if there are multiple networks coming in from multiple VPCs, we are able to protect from the connections that are coming in, just to make sure that our VPC, our virtual machines, are actually protected. And firewall rules are applied to the network as a whole. They are applied to the network, not to the exact virtual machine. And the connections are allowed and denied at the instance level, right? Now it might be that our connections have been sent to a particular virtual machine, and then we want to deny it at that, and the next virtual machine is working really well. So why to hinder that? Just as that. And there are all stateful and implied deny all ingress and allow all egress. Well, we'll talk about ingress and egress in the next slide. So in the next slide actually, but you'll understand what these are. All right. So we express our desired firewall configuration as a set of firewall rules. Like it depends how we want a firewall to act. So we make some firewall rules which we'll be making in our labs. and we make the direction of the rule, the source and destination of the connection, the protocol and the port like the TCP, UDP, action of the rule, the priority of the rule, 1 to 1000 depends the priority, the rule assignment and everything. So Google Cloud Firewall use case egress. So what is egress? Well, there are conditions for this to work. Destination CIDR ranges, some protocols and some ports. This makes sure it is egress. Well, the action is, it will allow, when will it allow? It will permit the matching egress connection, and it will deny the matching, it will block the matching egress connection. So these are the two actions it can do. So how does it happen? Well, this, as you can see, these are the firewalls, egress, this is the virtual machine, and this is the external host. Now if any connection comes through this, it can, like, say, it can permit or it can deny. So it can permit some matching like connections, or the egress connections, depending on the port or the CIDR ranges, and it can also deny on the basis of that. So this is egress. Now we come to ingress. Ingress is actually the incoming connections. So ingress connections, so the source CIDR ranges, again that is a condition, the protocols and the ports, and it will permit the matching ingress connection and will deny the matching ingress connection. So again we define that, so it will deny and permit according to the conditions that we put in. So we'll also have a lab on that, so you'll understand it better. Well, the Cloud VPN securely connects an on-premises network to a Google Cloud VPC network. So Cloud VPN, Virtual Private Network, will connect an on-premises network to a Google Cloud VPC network. How do we do that? Well, what does it do? Well, it is useful for low volume data connections, and it has 99.9% SLA, which is a very good SLA, and it supports site-to-site VPN, static routes, dynamic routes, and these ciphers. Well, if it's something that you really don't understand what is happening, you would, when you do the practicals, you would understand that, okay, how does it happen? So we'd be doing a practical on the VPC network, and maybe we'd be making a cloud VPN like connect to the server. Maybe we can do that. Let's see if it happens. And believe me, the practicals are much fun. So the Cloud Interconnect offers two options to extend on-premises network to a Google Cloud VPC network: Cloud Interconnect and Cloud Interconnect Partner. So they are both different plans. So these are the comparison of the interconnect options. You can actually look at that and understand what it is. Now we come to GCP monitoring. So the network that is coming in, we need to monitor that, and we need to see what is actually happening. So these are the Google Cloud's operation suite, like cloud monitoring, cloud logging, error reporting, cloud trace, cloud profiler, all of these things. So monitoring does all of these. It identifies trends and prevents issues. It reduces monitoring overhead, improves signal to noise, and fixes problems faster. Well, cloud logging, it seamlessly resolves issues, scalable and fully managed, all cloud logs in one place, that is very easy to handle, and real-time insights. So cloud logging, we'll also be doing a lab on this. Error reporting, we understand the errors very quickly. They are automatic and in real time. We get instant error notification. We'll also be doing a lab, which is very fun, and it can be used with very popular languages like Python, Java, Ruby, PHP, JavaScript, Rust, and a lot of that, right? Let's come to cloud trace. Well, find performance bottlenecks. It understands that what are the things that are making the performance really slow, and it can give us fast and automatic issue detection. It is broad platform support. Cloud Profiler is a low impact production profiling and gives us a broad platform support. So I think this is all for this theory session, and I hope you understand most of it. But even if you didn't understand some parts which were a bit more technical, I am sure when you do the practical you would really understand when you read through the documentation. It's really fun if you do it yourself, but obviously we'll be doing it with you, so that helps. Okay, so thank you so much guys. We'll be meeting you in the next video, the practical video.